right. Hi, everybody. My name is Kashawn Hopkins. You will and can refer to me as Mr. Hopkins. Today, thank you for coming out. First thing first, thank you for coming out. I know you're spending some of your after-school time. I know you could probably be home doing whatever it is when you go home. And so thank you for coming out here because, I mean, honestly, who does that? Who comes after school? So thanks for doing that, and or whatever they're using to bribe you. So thanks for coming out. Today I was thinking about using our time as wisely as I could, and I tried to think of all the types of problems that high school students usually have when they're in their math class. And one of them that came to mind, and it might apply to a lot of you, so let me kind of like paint this scenario and see if you can put yourself into it. So pretend that you're sitting in your math class, and you open up your book, and your teacher's lecturing at you, you get the lecture done, and you start doing some of the homework for being a good student today. This is one of your good days. And you get your pencil and you keep working and you're like, okay, this homework is pretty easy. I can get through it. I got through this problem. I'll work with my friend and do this. And then all of a sudden, out of nowhere, there comes this one problem that you're like, oh, this is math, but what are these words doing here? What are these sentences doing here? And you start freaking out, you panic, and you stop working. And those are nice little word problems. You deal with them all the time. And the reason why I think it's important that you don't stop and skip them and actually try to work them out, because word problems is a really nice way to connect English with math. We try to communicate with English. And so we're communicating our thoughts with the English words that we use. And if we translate them into math, we can kind of manipulate them using math and then bring them back into English and take all the important parts and actually learn something from it. So, today can I see a show of hands? Does y equals mx plus b linear equations, does that sound vaguely familiar from middle school-ish, high school? I just want to get an idea of where everyone's at. Okay, that's great. Among those people, or I guess the other people, it doesn't really matter. Among those people, who has encountered system of equations? System of equations, does that sound vaguely familiar? Okay, about roughly half of you. Okay. So today is going to be kind of a lesson about taking English words and word problems and then bringing it to math. And we're going to do a little bit of math. We're going to do some system of equations and linear equations. And then we're going to take whatever we did with in math and translate it back to English. So is everyone ready on that one? Yes? Great. So let me start. Okay, let me start with something very simple. We're going to use some algebra. I think a lot of you have already had algebra. And one of the really nice things about algebra is it helps you find unknowns. Usually you're trying to make some kind of prediction, but the ultimate goal is to find out things that you don't know yet. And for an example, a really just small example, so you like apples. Pretend that you like apples, or you can translate it to some other kind of food that you like. And you have like a basket of apples. You don't know how many apples are in that basket, but you know you do have a certain amount. So I'm going to label that as X. So into the night, you go to sleep, you put up your apples and you go to sleep. And in the night, someone breaks into your house and steals 5 of your apples. So he steals 5 apples. And you wake up in the morning and go, oh no, there was an apple thief. And he came in, stole my TV, stole my laptop, but the only thing really important that they did steal were these apples that I love oh so much. And you count how many apples you have left, and you have 3 apples in there. So now what you ultimately want to figure out is how many apples you started out with. So nice little algebra equation, and all I did was I kind of talked myself through it by starting with what I don't know, X. I labeled it X, but X is how many apples I have. X equals apples. I started with. Can everybody, I'm going to move in a second. Can anybody in the very back, can you guys kind of see my chicken scratch here? Sort of, kind of? Yeah. Okay. So first I started with what I know I don't know, which is how many apples that I had altogether in the very beginning. Then I kept going by turning the thief who stole my apples into a sort of an expression, x minus 5. So if I knew how many apples that I had and take away 5, then I could find out how many apples I started with. And I continued and said, okay, so at the very end I had 3 apples. So something like this, if you take a very beginning algebra class, you can solve by adding 5 on both sides. Add it on the left-hand side and add it on the right-hand side. And that ultimately solves to 8 apples. I started out with 8 apples. And so that's just a very simple example on how you can start with an English sentence, just like that story I told you, as ridiculous as it was, and move on to something like you can conclude that you had 8 apples. And so let me bring it on to a much larger example. I'm going to move into the system of equations, and if you don't have it, don't worry too much about it. I'll try to explain as much as I can. And we're going to start from linear equations, and then we're going to move on. So let me read this really quick. Does anyone need this? Everyone understand this example? Okay. I like how quiet you guys are. You guys are pretty great. Okay. So our very first example is number 1 on your papers there. And I accidentally made a big, huge typo. I didn't even realize it until like halfway on my drive over here. I was looking at it. And change the dollar amount. It's $1.45 originally. Change it to $2. I had it that way before, but it turned out to be really ridiculous. So I changed it to $2. So I don't confuse you. Go ahead and change that right now. And someone in the front, can I borrow your paper? Thank you. Okay, I'm going to read this aloud, and then I'm going to sort of kind of break it down, because we're starting in English, and then I'm going to break it down into little bits of math. So, number 1, Stanley has $2 in dimes and quarters. If he has 10 coins in total, how many of each kind of coin does he have? Okay. So when starting with system of equations, what you're trying to do is you take the words and you turn them into 2 equations. And these 2 equations, you're going to use them to solve for 2 variables, 2 things that we don't know. And in this question, they asked for how many quarters and dimes we had. So I'm going to start with the question. That's usually what you want to start out with when you're dealing with some kind of math problem. Is start with the question. It asked how many of each kind of coin do we have? Someone raise their hand. What is the 2 coins that we're dealing with right now? Raise your hand. Somebody that knows the answer? Yes, very confident lady in the front. What are the 2 dimes? Dimes and quarters. We're starting with dimes and quarters. Very good. So for simplicity's sake, I'm going to label quarters Q. Quarters. And I'm going to label dimes D. So whenever we're setting up our equation, we're going to refer to quarters as Q, and we're going to refer to dimes as D. Does everyone understand? Yes. Yes? I see some nodded heads. How about you guys back there? Cool. All right. So next, a good way to kind of set up our equation, because all of our equations, if you write out equation, E, Q, U, A, T, I, O, N. That's a very important part of the equation, is that you include the equal sign. So equation starts with E, Q, U, A, and equal starts with E, Q, U, A. So never forget that you're always going to have some equal signs in your equation. So I'm going to first start, I have equal sign here, and equal sign there, because I know I'm going to have 2 equations to deal with. Okay, so first things first, you want to find a way to sort of organize all this information, because they told us we have 3 lines. Stanley has $2 in dimes and quarters. He has 10 coins in total, and then the question. So we want to kind of organize all this numbers that they're giving us into at least 2 parts. There's And a good way to kind of spot is if they tell you you have a total of something, then that's probably what you're going to equal on one side. So if he has 10 coins in total, that's one total that you can have. So 10 coins. I'm going to put 10 coins right here on the right-hand side of this equation. And on the very first sentence it says Stanley has $2, so that's also another total. $2. So a way to kind of organize this information based off of these totals is, the first total is how many coins that you have. So how many coins you have. Can you guys still see that on the very back there? Yes? Okay, cool, thank you. And on the bottom, this is monetary value. All right, so we've used the $2, we've used the 10 coins total. Now we kind of need to set up some expressions on the left-hand side, something that uses quarters and something that uses dimes, because we haven't used those variables yet. So let's start with, I'm going to start with how many coins that we have. So we should be able to set up some kind of expression using addition, subtraction, multiplication, and division with quarters and dimes to kind of make sense on, like if we had, let's pretend that you have quarters and dimes in your pocket. And you pull it out of your pocket and you want to count it up. You see that you have 5 coins, or in this case 10 coins. You have 10 coins. And you have 10 coins. And so if you want to separate your quarters and dimes, let's say you have 6 quarters and you have 4 dimes. If you wanted to set up your expression, you would sum up how many quarters you had and how many dimes that you had to get how many coins that you have when you add them all together. Does that make sense? If you want to find out how many coins you had all together, you would add quarters plus how many dimes you had. So pretend that you have 5 quarters and you have 5 dimes, and it would make sense that you have 10 coins. So that's one of the possible answers for this one. Another possible answer would you have 6 quarters and 4 dimes, or 7 quarters, 3 dimes, either one. So there's multiple solutions that you can put, there's multiple solutions that you can put in for quarters, and there's multiple solutions that you can put in for dimes. But what you really want is something that agrees, that solves this equation, and something that solves this equation both at the same time. Okay, and so if you're moving on to monetary value, how much is a quarter worth? Someone raise your hand and tell me. Yes? 25 cents. So one way to write that term is 25 cents times how many quarters we have. Because if we have 8 quarters, then you would plug in 8 into this little piece, and you would multiply 8 times 0.25, and you would get $2, right? Okay. So how much is dimes worth? Yes, ma'am? 10 cents. So I'm going to write that as 0.1 times D. Okay, so now we have 2 nice little equations that we can work with. Do you mind if I erase this? Is anyone using this up here? Okay. So next I'm going to translate all of this into something that we can graph. So, because one of the ways that you can solve a system of equations is by graphing. So I'm going to use Q plus D equals 10. I'm just going to solve for Q. I'm going to move everything on the other hand side and leave Q by itself. So I'm going to subtract D and subtract D on both sides. And so I have Q equals negative D plus 10. That's one equation that I can graph. And the other equation that I can graph is 0.25 Q plus 0.1 D equals $2. And so if I want to get Q by itself, I need to subtract the 0.1 D off the left-hand side and subtract it on the right-hand side. So I'll have negative 0.1 D plus 2. And then I want to divide everything by 0.25. So 0.25, 0.25, 0.25. So the way that expression comes out to is Q equals, let's see the sheet really quick. Q equals negative 0.4 for D plus 8. Great. All right. So these two equations I conveniently graphed on your number ones over there. And they both align at one point. What's the coordinate point? Anybody that's looking at the graph? Yes, ma'am?
5, 6.
5, 6. Very good. So we have this nice little coordinate 5, 6. Where this first 5 stands for how many quarters you have, and 6 stands for how many dimes you have. Oh, wait a minute. 5, 6. Oh, I'm sorry. There's an error on your sheet that I prepared. Hang on a second. 4, 8. Let me erase this really quick. So it looks like I don't have the right graph on that one. But I mean, I can pick out some points that I can use for the Q's and D's on that, but I'm not for sure if I have enough time to work through this.
We've got enough to work with, so
I do have time?
no.
No time? Okay.
So we'll finish this one.
Okay, we'll come back to this.